So we're going to be doing k closest point to origin today, LeetCode question 973. So what this question is asking is, given an array of points, where that array you're given your x and your y, you want to return the k closest points to the origin. So you're given an array, you're given k, which k is basically the number, your output, the number of outputs that you're going to have, and you want to have that number of outputs be the specific points closest to the origin. So how are we going to go and do that? Let's take a look at some of the examples that kind of visualize how this question and problem is going to play out. I think example 2 is the best example here. You're given 3 points, 3, 3, right? Where this 3 represents your x, this 3 represents your y. 5 and -1, -2 and 4, and your k equals 2. Remember how I mentioned how k is the amount of outputs that you want, the amount of points that you want to print out. So if k equals 2, then we want to print out the 2 closest points to the origin, aka 0, 0. And the closest points are going to be 3, 3, and -2 and 4. Perfect. So now we have an idea, at least mentally, on what needs to be outputted and kind of the way of thinking as a human, but how do we create that in code? So when you are given a question, specifically when it says k something, you automatically should be thinking of the heap data structure, right? What is a heap? So there are 2 versions of heaps. There's a minimum heap and there's a maximum heap. What they do is they basically think of it as sort of like a binary tree where you're going to have for the root, you're going to have a value. And if it's a minimum heap, then it's automatically going to rearrange the values and have the smallest values on top, right? And if it's a maximum heap, it's vice versa. So now as we understand that, what are we going to be using? In this question, how I'm thinking mentally and formulating is that we need to use a heap. In this instance, I am thinking a minimum heap. So how are we going to go and import that? Well, it's not like a hash map or hash set where we could just automatically do it. We do need to import something. So the first thing we're going to do is import a heap. Q, and this is basically going to represent a minimum heap, right? This automatically, by the way, rearranges values by itself, right? Remember the smallest, smallest value on top. Beautiful. So now as we've imported that, we're able to use the heap q function and basically work around and make sure that we have the smallest values on top and so on. So let me tell you the process of how we're going to use this heap for our benefiting, or how to solve this problem. When trying to find the distance, this is the first step we have to do. Remember how I mentioned that we need to return the closest points to the origin? We need to do a mathematical operation to kind of figure out what points are closest and what points are furthest, right? What mathematical operation do we do? Well, they kind of give it to you. The distance between 2 points of the x and y plane is the Euclidean distance, right? So it gives you this big operation and it looks scary, but after researching and kind of figuring out how to do this problem, it's really simple. And yes, this mathematical operation is the correct way in proceeding. However, with the things that we were given, all we really need to do is remove the square root and just get your x and square it, right? And get your y and square it and add those values together, right? So how that's going to look is something similar to this. I'm going to create a function so we can continuously call and do this because we're going to need to do this for each point. So we're going to create a function. We're going to name it distance, right? And we're working with x and y's, right? So we're just going to pass in x and y in our argument. This can be named anything, but for this example, we're just going to name it x and y because I think that's a little bit more easier to follow. And we want to return something, right? Because this is what this main purpose of the function is to do the mathematical operation and return a value. And remember how I mentioned that all we need to do is square x, which is going to look like this, right? Square by 2, just like in the equation, right? And remember, they have an addition sign, so addition. and then they have your y, and you just square it. So if you're just squaring y, it's going to look the same way, and boom. So now you have this function, and it's returning x squared, and you have y squared. Perfect. What next? Well, now we're going to create the heap. Remember how we imported it, so now we can use it. We're going to make a heap, and there you go. So this is our heap, right? And after the heap, we have our function. We imported everything. We are going to go and now loop through the x and y in points, right? And points is basically, remember I mentioned they given you an array. Let me show you the input. Points is right here. So this is what it's going to look like, right? You have multiple arrays within a list, right? The array represents each point. So 3, 3 is a point, 5, -1 is a point, -2 and 4 is a point, right? We need to loop not only through points, but also loop through the points itself. I know that sounds a little bit confusing, but what I mean is you see how this is all in one big bracket, right? You have a bracket here and a bracket here, right? That's a list. Inside this list, you have other lists. This is a list, this is a list, this is a list. We need to loop through not only each value, but once we reach the first value, so in this instance 3, 3, we need to be able to distinguish that this is our x and this is our y. Same thing here. We need to be able to distinguish that 5 is our x, -1 is our y, and for the right here, -2 is our x and 4 is our y. So how do we do that? By looping, right? So we're going to do for x and y in points, right? So, you can name this whatever you want. We do x and y for the simplicity so we can help follow this problem, right? And we are going to go and use those points and plug them into the function that we created. Because remember, distance needs 2 arguments, x and y, right? To return the distance. Well, we are now grabbing those points from every single list here, right? And why are we grabbing these points? To plug them in, right? So all we need to do is we're going to create a variable, and we are just going to call the distance function and literally plug in x and y like that. So now d is going to represent the actual mathematical distance that we've been looking for, and we're going to be able to use this if we make our conditions or whatever, right? So now as we've done that, all we need to do is, like I mentioned, create some conditions. So the first thing is length, right? We need to output k amount of values, right? So if k is 2, we need to output 2 answers. So how is that going to work? Well, we need to set a condition saying, okay, well, if the length of the heap is less than k, well, then just add the values, right? Else, then we need to start removing stuff, right? So this is how we're going to be using the heaps. We're going to make a condition, right? If the length of the heap is less than k, then don't worry about it for now, right? Because we can still add stuff. So heap q dot heap push, right? We're just pushing values, right? And we are going to just call heap, and I'm going to write it down first and then I will explain, right? We're going to put the distance and the y. Beautiful. Right? Perfect. Else. So this is if the length of heap is less than k, right? And this else is basically heap q dot not only push, but as well as pop, right? Heap, and then you're going to have the same thing here. Okay, what is going on here? Let me explain. So you're checking if the length of the heap is less than k, right? If it is, then just add, we are not popping anything, and we are making the distance negative. So what this negative d represents is literally this. So let's say, for instance, we grab the values 3 and 3, right? D equals distance, x and y, or x is 3, or y is 3, and we're plugging it into the distance function. So that's x squared, our x is 3, so 3 squared is 9, plus y squared, our y is 3, y squared is 9, so 9 plus 9 equals 18. Beautiful. Negative d represents negative 18. The reason why we're making these numbers negative is, how do I explain it? So d is the distance, and we make it negative, and we do this to push the higher values on top so we can remove them later, right? Because remember, we're trying to put the higher values on top and keep the closer ones or the lowest ones in the bottom, because when we pop something, it removes the first value, right? We want to basically continuously pop values if it's greater than k, right? So if the length is greater than k, we're going to be popping values because we don't need those values. We need k amount of values. That's why if they tell you to print out 2, when k equals 2, you're going to have 2 points, right? Beautiful. The way we're going to do this automatically is by putting the higher values on top, right? And removing them because we don't need the higher values. We don't need the values with the most distance. We're looking for the closest distance to the origin 0, 0, meaning we are looking for the lowest amount of points. So when you put negative d, negative distance, that puts the higher values on top, allowing them to get popped first. So with that being said, and now we kind of understand what's going on and the things that we need to do in order to reach that conclusion, that is why we're turning this d into negative. This is why we are pushing if the length of the heap is less than k, because we could still add values. Once it's not less than k, that's why we do not only push, but pop. So the heap push pop, what that does is it's going to push the value, the right value first, right? Whatever is closest to the point, and pop the highest one, or the first point. Remember, the first point are the highest values. That's why we're pushing those onto the top, right? It's going to remove that because that's the furthest away from the origin, and add the new one. And as we go, it is going to be continuously rearranging itself for us. Remember, heap Q automatically rearranges the values by itself, putting the smallest values on top. So when we put negative d, it basically follows heaps Q's pattern, automatically arranges the values, so we don't need to necessarily push anything by ourselves. All we need to do is just remove, right? So with that being said, everything should be pretty fine now, and we just need to return x and y from the heap. So how that would look is literally just a return statement, put it in a list, because remember, we want to output a list, and we are going to just do x and y for, so we're doing a for loop with this return statement. This is a really nice way of doing it. D, x, y in heap, right? So if you do not understand this line, that's okay. I didn't understand either when I first looked at this, but we're returning x and y for d, x, y in heap, right? So remember, heap looks like this. Oh, we're right here. Heap looks like this, right? And you're gonna have negative 25. This is just random numbers. 3 and 4, right? And this is gonna represent d, this is gonna represent x, and this represents y, right? So when you say return x and y for d, x, and y in heap, right? So this is a for loop, this line that's highlighted, d, x, and y, right? D represents negative 25, x represents 3, y represents 4, right? In heap. So when we say return x and y from heap, we're basically saying return 3 and 4 from the heap, right? And have it in parentheses and within this list. And that's why when you output them, this is exactly what it looks like, right? So with that being said, I think everything here looks good. I'm doing a rain check. Let's give it a run. Let's see if everything is working. The fact that this test, oh, okay, now I was about to say this test was taking a long time to run. Let's give it a submit, make sure we pass all our test cases. It is, okay, yeah, oh my goodness, I guess that's just the LeetCode website messing up. All right, perfect. So it's been accepted. Everything works. Some takeaways. Just remember, if you find the K of something, automatically think you're using the heap data structure. In this problem in particular, we create our own function with the argument x and y. This is the mathematical operation. It's called the Euclidean distance, right, to find the distance of the value. In this particular question, all we needed to do was just get the x and the y, square and add it to one another. We call the heap. Remember, we import the heap q. Heap q represents minimum heap. We do a for loop with x and y in points. Points is this gigantic array. Remember, it's right over here. We have two values that we created, x and y in points, because there are multiple values within the list. So that's why we do that. We call the function, we set it to a variable. So that when I say function, the distance function, we pass the x and y points that we created for the for loop. We set some conditions here, making sure that the length of heap is less than k, then just push. If not, then this is where things get a little bit, I want to say complicated, but this is when we start using the methods in order to solve this problem that we are implementing. This is kind of like the bread and butter here, where we start not only pushing, but push pop, removing the values from top and leaving the lowest at the bottom, because we are looking for the lowest AK, the values closest to 0, 0.